let's keep going with our same example using diamond as the medium. But this time we're looking at a different formula. We're looking at n is equal to the real depth over the apparent depth. So we should recognize that now we've gotten about 4 different ways of calculating the refractive index of something. You have sine I over sine r, you have 1 over the critical and 1 over sine of the critical angle. You have the ratio of the speed of light as it moves through the medium versus through the air. And then now we've got the real depth over the apparent depth. And all 4 of these will calculate the refractive index, or will use the refractive index depending on how you're using the formula. So I'm going to pretend that we've got a lump of a cuboidal lump of diamond that has a height of 7 centimeters. Okay, so the height of the piece of diamond that we have is 7 centimeters, and we place this block down on top of something in such a way that we can see a mark. It's left on a table and there's an X on the table. So here's my block of diamond, worth a lot of money, and it's 7 centimeters high here. So this height, as it's sitting on the table, is 7 centimeters. And in here somewhere, I've got an X marked on the table. But as I look straight down on top of this block, the X doesn't look like it's 7 centimeters depth. It has a different depth. So we're looking straight down this way, and we see the X somewhere higher up like this. And the reason is because we're looking through, there's refraction going on, and it's given us an apparent depth. And the question is, what's the apparent depth here in this case? Well, the real depth of the X is 7 centimeters, and we have the refractive index as being 2.4. So we have n equals 2.4, and we have the real depth is h, which is 7 centimeters. And so to answer this question, we fill in the formula again. So n is equal to real depth over apparent depth. P will do for that. DEPTH depth. So we fill in 2.4 is equal to, well, the real depth is 7 centimeters over the apparent depth. And now we have to find the apparent depth. So if we sort of juggle this formula a little bit, we'll end up with apparent depth is equal to 7 over 2.4, like that. So the apparent depth in the thing would be 7 divided by 2.4. And we get a value of 2.92 centimeters. Now, you'd have to be careful with this question, because at times it would ask, how far off the desk surface does the image appear? And this is the apparent depth. So that's starting at the top. Instead of looking like it's 7 centimeters away, it looks like it's 2.92 centimeters away. So in order to see, well, how far above the desk does the image appear? So you need to make sure that you're answering the question that's asked here. You need to check the question just to be 100% sure. Well, how far above? It would be 7 centimeters minus your 2.92 centimeters, which will give you 7 minus 2.92, give you a value of 4.08 centimeters, if that's what was asked. So this, if it's asking you what your apparent depth is; this, if it's asking you how far above the desk does the image appear.